Hello, Anatomy and Physiology. It is Mrs. Lloyd here. I am enjoying some of my breakfast this morning. Well, partially because my wonderful husband brought it to me while I was getting ready for this video, but also it fits in perfect with our talk about the stomach. Poor Norm over there is thinking he's going to get some. He'll definitely get to lick the plate. All right, so we talked a lot about the stomach yesterday, but there's a few other things that I want to make sure that we go over when you get down for your homework assignment. So I wanted to include this picture again. I found this great graphic that shows all of the major functions. It's basically a word version of this colorful picture that we have here. I did encourage you guys to sort of color code on your black and white packet. Because you can see what parts of our digestive tract have what different processes going on in the entire alimentary canal, the entire GI tract. So for example, the mouth and the other accessory structures in there has a variety. We have listed here 4 different functions that the mouth does. It is the only place where ingestion occurs, or is supposed to occur. The video I want you guys to watch today, the crash course video, is going to go over a little bit about this interesting gentleman who had a hole in his stomach, and a scientist was feeding him straight into his hole, into his stomach, to study and learn about processes of digestion. But other than him, most of us ingest through our mouth. And we end up having other events as well that occur here. So as you can see on this picture here, we've got propulsion. Okay, as I just ate and swallowed that little clementine piece, I did the process of swallowing and then pushing that food down. It's probably traveling down my esophagus and getting close to my stomach at this point. Now, if I were to say leave just without chewing it up and swallowing the clementine, or maybe my little Jolly Rancher here, I would actually be able to do digestion, chemical digestion in my mouth because of salivary amylase. Now, I also mechanically break down that food through chewing as well. So there's 4 different processes that happen in the mouth. Your esophagus, this one is not the star of the show by any means. It's just the tube that connects your mouth to your stomach. The only thing it does is propulsion. Our stomach, we're going to get into this in more detail here, but it has 4 different functions. You can see propulsion. It's kind of right here. And I'll talk about that in more detail. When we get into the intestines is our main side of absorption. It also is going to continue on with digestion, chemically breaking down the food. There's mechanical breakdown through that process of segmentation, that like mixing action that it does. And then obviously it continues to push your food through. So propulsion, if you notice on your diagram in your packet, this teal line goes all the way through the entire tract. Propulsion goes from mouth to anus the entire way. All right, then we get into the large intestine. Digestion still occurs, not very much, but a wee bit because of the bacteria breaking down a little bit of things that maybe you can't break down, things like fiber and stuff like that. Absorption happens. A lot of our water gets absorbed here. Propulsion, obviously, and then defecation. That is only one step, just like with ingestion only has one step. Defecation only has, one organ in which it does that. Unless maybe you had a colonoscopy, not colonoscopy, excuse me, one of the little like pouches, because part of your intestines have been removed, and so basically you end up having a pouch coming off of your either small intestine or large intestine, like my grandpa does. All right, so this will help you with some of the homework assignments, so you can always access this slideshow later. If you wanted to, you could go through on this page from your notes packet. Let's see, that's on page 11. You could even just write like the first letter of each organ as you kind of go through that, like what organs do chemical digestion? Which one does ingestion? Only one, the mouth. So maybe I'd put a little M next to that. Which one does defecation or elimination? Only one, your large intestine. But propulsion, I would put everything down, right? And absorption, right? And I'd go through. So if you wanted to sort of keep track of what organs do what, this would maybe be a good place in your notes to note that, but not necessary. Okay, so these were the notes from yesterday. This page should be filled out, but I wanted to add a few things for us to go over. So we're talking mostly about the stomach here. My stomach is processing some of this food that I've eaten and have enjoyed. Here's a little OJ for me. That's high in carbs. My salivary amylase would be working on it, and I can feel the saliva forming in my mouth just even looking at and smelling and enjoying this juice. And we have a few things that I wanted to go over with you about the stomach in particular. Now, as we mentioned yesterday, your parietal cells put out hydrochloric acid, and this acid is very, very strong. It's stronger than battery acid. So when you are producing hydrochloric acid in your stomach, what prevents that acid from dissolving and destroying your own stomach? Well, that's where those mucus cells come into play, right? So these mucus cells and the mucus neck cells both create a protective mucosal barrier. The mucosal barrier, super important, does a few things. First of all, the mucus is bicarbonate rich. Bicarbonates basically counteract the activities of acids. Oh, is Jeffrey trying to get in here on today's lesson? And so that mucus, because it's the bicarbonate, it sort of prevents the acid from reacting directly with the cells. It also, we have really, really tight junctions. This is throwback from our cells unit, really tight junctions that form between all of those simple columnar epithelial. That is what those mucus cells are. You can kind of tell from the shape here that these are one layer of columnar shaped cells, but they form tight junctions so things can't get in between them. And the cells in your stomach is one of the most quickly replacing cells in your body. We talk about like hair, it has a pretty fast reproductive rate, mitosis. Well, your stomach lining is probably the fastest reproducing cells in your entire body. And so these cells get lots and lots of regeneration, lots and lots of stem cells that take care of that. All right, so I breezed over, as we talked about the different functions of the other organs, I breezed over the stomach because we're going to list a few of them out here. So your stomach obviously propels food, right? It empties in, basically as food comes through, it drops in through this cardioesophageal sphincter and drops into the stomach, okay? The stomach will continue when it's ready to push it out that pyloric sphincter and can continue the movement of food on through. So propulsion. There's mechanical digestion through the churning action. So it's going to be mixing and breaking up that bolus of food. So it's called a bolus as it moves from your mouth down to the esophagus. But once it gets mixed up in your stomach, we call it chyme. C-H-Y-M-E, chyme. I'll talk about that in the video, but the mechanical digestion continues to occur. And then the chemical digestion also occurs. So the main chemical we talked about yesterday was pepsin. Pepsin breaks down proteins. That's the main chemical that affects. The acid does do a good job of breaking some of the molecules up into smaller pieces, but really the acid there is to activate pepsinogen to turn it into pepsin. So the acid doesn't actually do that much of a digestion. It's actually the pepsin that breaks down the proteins for you and the chemical digestion. And then absorption. Now, Your stomach is not the main absorptive organ of your whole tract. Really, the small intestine is the main one. That's why it's so long, and we're going to talk about that in more detail coming up. But there's a few things that your stomach can absorb, and these are things that get into your bloodstream the fastest when you drink it. And I say drink because many of them are liquids. Alcohol, right, is one of those main things. Alcohol gets absorbed into your bloodstream very quickly. This is why alcohol can have like the very fast effects that it does on people. It gets absorbed straight into the stomach. Also, aspirin has a really, once you've taken like some aspirin, ibuprofen is not an aspirin, not quite the same, but aspirin gets absorbed very quickly into your stomach. And caffeine is another very quickly absorbed substance. There's a few other medicines out there, and sometimes pharmacists are going to design, not pharmacists, but the drug companies are going to design drugs that can get absorbed quickly. If you need something fast acting for an individual, they want something that's going to be in that realm like the aspirins are to get absorbed. There's a few vitamins as well, but these are the three main ones that get absorbed. Nothing else really. Like my sugars, no. My proteins, no. My fats, no. Okay? Those sorts of things don't get absorbed. All right. The other important chemical that your stomach does, and these are all good things that you should jot down in your notes somewhere on this page, off to the side in the margin, doesn't matter. But your stomach secretes, other than pepsin, this thing called the intrinsic factor. And it doesn't break things down, but what it does do is later on in the digestive tract, it makes it so you can absorb vitamin B12. And that is an important vitamin for helping break down a lot of proteins in eggs, one thing I am enjoying right now. And so my stomach is going to be secreting some intrinsic factor in order to allow for that B12 absorption. And then a for fun video that I've posted today is how big can your stomach get? How much can you eat? I enjoyed a lot of snacks last night, and my stomach felt very, very, very full. We're going to talk about the brain connection to your stomach, but right, your stomach can hold 2 to 4 liters of food. 4 liters is a lot of food. So like the fullest your stomach usually can get is up to 4 liters. That's a lot. That's a lot of food. Now that's mixed in with some of the gastric juices and other liquids and things like that. But yeah, you can absorb, you can hold a lot of food. And when you think about people who are like food eating contests, champions, things like that, they can train their body to maybe even do a little bit more. But on average, you can eat up to 4 liters, which is a lot. Okay. All right. We won't fill this whole thing out on your notes here today, but this is, I think, on the back page, page 12. So there are digestive hormones that control the other glands to release their substances. And so when we get into the intestines, there's obviously some more that we'll get through, but for our stomach, the hormone I want you to know about is called gastrin. And so you can think gastric acid, stomach. Gastrin is a hormone, and it is secreted by these cells called the G cells that are located in your stomach. Now, this gastrin hormone affects all of those other important secretions that we've already talked about. So the acid, hydrochloric acid, that's secreted by our parietal cells. This is review for you. Okay, our mucus is secreted by MNC, the mucus neck cells. And the other one on here is goblet cells. We've mentioned those before, but they're just mucus secreting cells. Anytime we've got our mucosal layer or mucus membranes in our body, goblet cells are usually the ones secreting those kinds of mucus. And then pepsinogen, which gets activated and turns into pepsin, is secreted by your chief cells, and those chief cells are secreting pepsinogen as well. So gastrin has an effect on these different cells, the parietal, the mucus cells, the goblet cells, the chief cells, to secrete their secretions. The other thing that gastrin does, that's not listed on here because it doesn't affect a cell, but it does affect a large effect. I want you to draw another little bracket coming off of the top here. The other thing that gastrin does is it tells your stomach to start rumbling and moving. So as I'm eating my breakfast here, my stomach and intestinal movements are becoming more active because of this hormone. So the first bites of food that came through into my stomach is going to stimulate the rest of my intestines to continue their movements. All right. So how do we control our and like all these digestional things, like, what is this brain and gut connection? This diagram is on page 878 of your textbook. There's way more detail on this than you need to know, but I do want us to talk about these 3 different phases and what happens. So on page 11 in your guys' notes, you have a little bit of space at the bottom. We're going to write like a small little table here. But before we get into that, I want to just kind of show you this different pictures. Now, this side of the diagram is showing what inhibits these different actions, like to tell, your stomach to stop churning and stop secreting acid. We don't want to do it all day long, every day. And so this goes into that, not necessary, that for the test. But the cephalic phase, think your cephalic region, right? That's your head, your brain. So what stimulates that is basically your sight and thought of food. And so the main nerve that stimulates your stomach is the vagus nerve. That's one of the cranial nerves that wasn't required for you guys to learn, but the vagus nerve was one of those cranial nerves that affects your stomach actions. The gastric phase, okay, this is when food first reaches your stomach, and it's going to secrete gastrin, which is then going to stimulate all those cells to secrete their digestive components. And then there's also an intestinal phase as well, but we are going to call that, the intestinal phase, excuse me. So anyways, on the bottom of your page here, page 11, I want you guys to sketch a little small table underneath there. So they call this your entire nervous system, actually, is called the enteric nervous system. And what's super cool is that you have nerves all throughout your digestive system, and they're not all connected to the brain. Some are, okay, but not everything is. So some people describe it as your brain gut, right? Or we sometimes describe like a gut-wrenching feeling, or like you're going with your gut, okay, those sorts of things. Now, that's not necessarily saying that it's not connected to your brain. Usually when you're like, I don't know, I'm going to go with my gut on this and just go do it or whatever. That feeling is not actually from your stomach, but your whole GI tract has its own separate nervous system, and it's called the enteric nervous system. But it is also connected to the brain. So it's not totally separate, but it has its own interesting controls. Now, the part of our nervous system that does control our regulatory digestive functions is that parasympathetic nervous system. So if you remember from when we did, in fact, we're doing nervous system in the intro class right now. So all of this, my notes here are handy, but we drew kind of a little graphic of like the different ways and the divisions that our nervous system is controlled. We get down to the autonomic nervous system, so all those things that are automatically controlled, and then you have your sympathetic, the fight or flight, or the parasympathetic nervous system. And if you can remember, parasympathetic means rest and digest. And so this parasympathetic nervous system is what controls your digestive functions. So normally when you are at rest and you're not stressed, your digestive system should be running off of the parasympathetic nervous system or on its own, because it has its own nervous system. All right. So for each of these phases here, we have something that stimulates it, and then we also have what its effect is on the body. I'll make my screen a little smaller so we can show all this. All right, so the cephalic brain stage here, the stimulus of it is the sight, smell, and thought of food. So I haven't finished my breakfast yet, but I've eaten enough in order to keep that stimulus at bay a little bit, because some of it's getting to my stomach by now. But this food sitting in front of me, all right, is making it hard not to eat it while I'm making this video. Last night, I was watching a show where they were eating cereal, and I just had to get up and make myself a bowl of cereal because of the sight of food, and watching somebody else eat it made me want to eat it that bad. This is why I was so full last night. Okay. Now, the effect that the cephalic phase has on your body is it starts stimulating those gastric glands before food even gets there, saying like, I think food might be coming. I can smell it cooking in the kitchen. Let's get ready to rumble. You might even start salivating because the thought of food is coming, right? And so that's the cephalic phase. Now, if you're already full, okay, this won't be activated, or you're not interested, or it's something you don't like, right? Your brain can be like, nope, I don't want that. All right, the gastric phase happens when the first bit of food hits your stomach. So that stretching that happens in your stomach, because your stomach shrinks and expands as it's empty until when it's full, a stretched stomach is going to stimulate the gastric phase. And what ends up happening in our gastric phase when it's stimulated, those gastrin is going to then kick in. So the gastric glands might get activated to start making, pepsinogen and HCl and mucus, but the gastrin doesn't come in until that first bit of food hits the stomach, and then all those enzymes get released. The intestinal phase, so the activities of my intestine, which is the next step after the stomach, when I have food that moves from my stomach into the duodenum, through that pyloric sphincter, just the first little bit trickling through, that first bit of food that's in the intestines is going to stimulate the intestinal phase, which it controls how often and quickly my stomach lets things out. So it's like a bouncer at the door. And that intestinal phase is going to say like, okay, we don't want to dump, okay, if I overate, okay, and I have 4 liters of food in my stomach, I don't want to just like open the floodgates and say 4 liters into my intestines automatically. I would have really uncomfortable movements for a few hours as that stuff is moving through my intestines. So the intestinal phase just says, okay, it's like a bouncer. It's going to say, all right, you two can come in, shut the door, let that stuff trickle out. All right, 2 more. All right, let that stuff trickle out. And so it regulates my stomach emptying is what it does. Or it can speed it up depending on how the stomach, the small intestine's processing. So your stomach is sort of a holding place. Okay, and that pyloric sphincter is kind of like a bouncer, but it's regulated by this intestinal phase. So by the first little bit of food that comes in, it's like, okay, let's start regulating how much gets in here to make sure everything gets absorbed nicely and neatly. All right. I really, really want you guys to watch this second video in the series for the digestive system. Before spring break, I had you watch video 1, but some of the assignments from today, the homework questions are going to be got from that. Also, all the things I talked about today, you see in the diagrams, I think animations are nice to see and view that way. Also, you get to learn about a guy with a hole in his stomach. Anyways, thank you guys for listening today. I hope you are well, and make sure and eat something delicious today.